we want to graph r equals 2 plus 2 cosine of theta plus identify the type of graph that we're dealing with. Well, this equation is of the form r equals a plus a cosine of theta. For that reason, the graph is going to be a cardioid. To obtain the graph, the first thing that we want to do is check for symmetry. So let's first check for symmetry with respect to the polar axis. To do this, we replace theta by negative theta. So we're going to have r equals 2 plus 2 cosine of negative theta. But the cosine of negative theta equals the cosine of theta because the cosine function is even. So r equals 2 plus 2 cosine of theta is an equivalent result. Therefore, we do have symmetry with respect to the polar axis. How about symmetry with respect to the line theta equals pi over 2? To check for this type of symmetry, we replace theta by pi minus theta. So we're going to have r equals 2 plus 2 cosine of pi minus theta. So we have a cosine of the difference of two angles. We need to use that difference formula. That's going to be the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. So we have 2 plus, now the cosine of pi is negative 1, the sine of pi is 0. So this gives me 2 times negative 1 cosine of theta, which is 2 minus 2 cosine of theta. So this equation is not equivalent to the original equation. So the test fails. What this means is that the graph may or may not have symmetry with respect to the line theta equals pi over 2. Why? Because these tests are sufficient to show symmetry, but they are not necessary to have symmetry. Next, we'll check for symmetry with respect to the pole. To do this, we replace r with negative r. So we get negative r equals 2 plus 2 cosine of theta, which is clearly not the same as r equals 2 plus 2 cosine of theta, so the test fails. The graph may or may not have symmetry with respect to the pole. Now, because we know we have symmetry with respect to the polar axis, all I need to do is plot or choose points or angles theta from 0 to pi and then use the symmetry to find the other points. So for example, I'm going to choose 0, pi over 6, pi over 4, pi over 3, pi over 2, and then I'll also choose 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. You should notice that these are the key angles whose exact values we know, and that's why I'm choosing them. So for example, when theta is 0, r, remember, is 2 plus 2 cosine of theta. So I have 2 plus 2 cosine of 0. Cosine of 0, you recall, is 1, so I have 2 plus 2, or 4. Continuing in this fashion, I get that when theta is pi over 6, r is 2 plus the square root of 3, which is about 3.73. At pi over 4, r is about 3.41. At pi over 3, r is exactly 3. At theta is pi over 2, r is 2. At theta is 2 pi over 3, r is 1. At theta is 3 pi over 4, r is about 0.59. At theta is 5 pi over 6, r is about r is about 0.27. And at theta is pi, the cosine of pi is -1. 2 plus 2 times -1 gives me that r is 0. So now what I can do is the following. Plot the points 4, 0. Remember, points are plotted in the form r, theta. 3.73, pi over 6, etc. If I plot these points and trace in a graph that's in the shape of a cardioid, I would get the top half of this graph. Then, because the graph has symmetry with respect to the polar axis, I can take the top half of the graph and use that symmetry to fill in the bottom half of the graph, and here's our cardioid.